The arsonist has oddly shaped feet. The arsonist has oddly shaped... Oh, you guys are here. Oh, guess it's time to play the music. Hey guys, and welcome to this week's show. I am honored to have Ryan Berry back with us. Ryan is, of course, a cloud solutions architect. Ryan, how's it going?
It's going well. How are you?
I'm doing well, man. I invited you to come do another show because, number one, everybody loves Ryan Berry.
Thanks.
That's just a given. And number two, a lot of people are asking about ExpressRoute, which is interesting. In itself, but it's also interesting because a lot of people kind of have it wrong. And so I think what we'll do today is kind of dispel some ExpressRoute myths, if that's okay with you.
Yeah, absolutely. Yeah. ExpressRoute is just one of many ways that customers can use as a vehicle or on-ramp to access services they have deployed in Azure. So we can kind of compare and contrast some of those methods customers have to access, and ExpressRoute being one of them. Actually, even within ExpressRoute, there's flavors of ExpressRoutes and options and peering options, and different provider models. Different ways customers can connect up to us. So we can walk through some of those. I think that'd be a great idea.
Yeah, awesome. Yep. So I get this a lot, right? Hey, I hear that you guys have ExpressRoute. Yep. Mm-hmm. We do. Isn't that just like a fast internet connection? Well, no.
Yeah, the interesting thing about that, we're first and foremost, we're not a carrier, so we're not an AT&T or Verizon. It's a path, interconnect path that customers can use to bridge their network to our network, and they need to do that using either a connection with a carrier, a network service provider. Or using something that we call an exchange provider, and we can kind of talk about those differences. And I show some slides here in a couple of minutes. But at the end of the day, customers actually have to provision some sort of pipe size, and traffic that they have originating from their offices or their locations into Azure or Office 365 will ride that pipe. So it's just an on-ramp, if you will.
Yeah. The way that I've been explaining it, and I'm hoping this is right, is say you built a building across town, right? And you had to connect your physical network to that building across town. You wouldn't go across the internet. I mean, you might as a cheaper solution, but more than likely you're not going to do that. More than likely, what's going to happen is you're going to call a provider. You're going to get a dedicated pipe between your network and that network, and you're going to build a private link between your buildings in that city or your buildings in different locations across the state. And that's kind of the basic idea behind ExpressRoute, right? It's private. It's not over the internet. It's something that that you maintain and you control via the provider that you select, and it gives you a direct link into our data center without going across the internet.
You got it. Yep. So customers have control over how routing works. How tunneling of traffic works, and we can go and talk about some of those options here. When I flip over to some of the slides, we'll walk through.
Tell us a little bit more about that, Ryan.
Sure, absolutely. So as I mentioned, that ExpressRoute is just one of many ways customers can establish connectivity from their network into Azure, and starting with the simplest of ways, leveraging the public internet, customers can just establish a VPN connection, using dedicated devices that they have, Cisco devices or, Windows Server, using routing or remote access service actually is a supported endpoint that can actually establish connectivity into a virtual network that a customer has defined into Azure. So while this traffic is encrypted, using IPsec, it is reliant on public internet pathways to be able to allow that traffic to actually flow to and from the customer's environment into Azure. So there's some inherent disadvantages to that, and that the customer is reliant upon, or never necessarily reliant, but it's there's some unpredictable performance that could come into play. throughput and latency might vary depending on time of day and the routes that are used to be able to allow that traffic to traverse through the public interwebs to and from the customer into Azure. So ExpressRoute changes the mix a bit in that, and as we already talked about, that it's a direct connection that the customer can establish from their network into Azure, bypassing the public internet. So you see here, we don't have any lines going up here to the public internet, cloud here up in the upper left-hand corner. And there's a couple ways customers can do this. One is using something that we call an exchange provider. So in the U.S., predominantly the exchange provider that exists in more locations than some of the others is Equinix. And the way that works is the customer actually deploys equipment into an Equinix facility, into a cage in an Equinix facility. We drop in a Azure network connection that goes to essentially an edge router or that is on our what we call our dark fiber or the Azure backbone. So it's internal traffic that's not ever going to go onto the public internet. So traffic, the customer is accessing a server they have deployed into Azure. That traffic is completely bypassing the public internet and will flow over our fiber links into whatever data center region the customer has their services deployed into. So this is more of kind of a point-to-point type scenario that the customer would have to establish this connectivity, from each one of those locations, to a ExpressRoute exchange provider, which would get them onto our backbone to have that traffic flow to and from. A third option is using a network service provider, and this is something that a customer can actually leverage, MPLS connections or infrastructure that that companies like AT&T and so forth already have in place to actually connect up their sites into the network service provider's network, and that network service provider has a connection into Azure. So with setting up routing, the network service provider would set up routing properly to have that traffic again ride our private backbone. So again, we're not touching the public internet for traffic from any one of these sites in this picture to hit any location in Azure. And we'll kind of compare and contrast that farther here in a minute. ExpressRoute is actually in a number of locations. So we actually have 28 regions that Azure is actually available today that customers can actually stand up services in. And subsequently, we have a number of partners in carriers that network service providers that customers can connect to, or ExpressRoute or exchange providers that customers can actually connect up into to be able to bridge their network into Azure. So this is just showing a number of locations and some of the interconnectivities that exist between some of those locations. So we have on-ramps basically all around the world that customers can use to wire up their locations, branch offices, or sites to get onto the Azure backbone.
So you're saying that these are all places where we have routers on site that have direct connectivity?
Yep. So these are all exchange points, if you will, that customers can bring in a circuit to if they're using an exchange provider, and from that exchange provider, they would then gain access to our private network, or some of these companies that are shown here, like the AT&T and Verizon. These are carriers that customers can actually use a network service provider option, and make use of MPLS networks, network connectivity from their offices. Again, allowing them to get into Azure. So you're using one of those two options that I showed in the previous slide.
Yeah. And one thing that I want to point out, I know you and I understand it, but I just want to make sure that everybody that's listening to this understands that when we say exchange provider, we're not talking about Exchange, the email project.
That's correct. Yep.
Yeah. We're talking about a company that has essentially an exchange or a interface into our Azure network.
That's absolutely correct. Yep. And as we highlighted on the previous slide, that path would be more kind of the point-to-point connection between a customer site and the exchange providers, where they actually have to deploy equipment in the exchange provider. Kind of think of it as a demarcation point, I guess, for lack of a better description, where customer deploys equipment into it, and that exchange provider wires up their equipment to the Azure network.
Yeah.
Yep.
Okay. Cool.
All right, and so there's a couple of options that customers have once they establish connectivity using ExpressRoute into Azure, and we refer to them as peering options. So basically, if you picture the customer's network here on the left-hand side with edge router equipment that they have, within their premises and facility, as the on-ramp into Azure, using that exchange provider, the network service provider. And then we have, the actual connection to, the Microsoft Edge router. So there's a couple of paths or options you have to take into consideration. First off is the easy one to talk about is a virtual network that exists in Azure. And you and I talked about virtual networks in the past, and we kind of set up connectivity in between multiple locations and I VPN. So this is the easy path to talk about. So the customer has a VM deployed into Azure as an example. That VM is going to be sitting in some defined network that's in Azure, and the customer, when they go to access that server, they'd be doing so using a private IP address, and again, it wouldn't be traversing the public internet. Where things get a little bit more interesting is when a customer has a need to access HT Insight or Azure Storage or Azure Automation, what we call the Azure, as it shows here on the slide, is Azure Private Services. But these private services are exposed to customers using public IP addresses. So customers can actually set up something called public peering, which means that when a customer accesses one of these Azure services that are hitting, that are sitting on public IP addresses that we own, that traffic can be forced to go over this ExpressRoute circuit as well. The advantage here being that there's a lower latency connection, a higher throughput connection the customer has directly into our the services running in various locations around the globe. But the disadvantage of this is that the customers have to realize that our pool of public IP addresses is huge, and basically the customers is allowing access, if you will, to any of those public services, with traffic flowing over their ExpressRoute connection. So there's some things that the customer has to kind of think about when using that particular option. There's another option. The customers can actually use peering for Office 365 and soon actually CRM Online, where customers can actually use that same connection to connect into those public services as well. ExpressRoute is not an inexpensive connection, so for Office 365, so sometimes public internet connectivity is acceptable for things like email and those types of services. But if customers are doing things with BI or using SharePoint for file synchronization, or using Skype for Business heavily for meetings and video sharing or video conferencing, that might be ExpressRoute might be a good consideration for customers to think about. And one thing to note when I talked about the public peering is the way this actually works is we actually NAT, or use network address translation, much like your broadband router at home. We have an IP address that's actually at the Microsoft Edge router, and we NAT the traffic coming from the customer's network into those public services, and then have all of the reply traffic sent again back over that ExpressRoute pipe. So this is just some additional information comparing and contrasting that network service provider to exchange provider. So that the earlier slide, I had a very simplified diagram that I used to articulate what the differences were between those two connection options. And this is just highlighting again with some bullets, and we'll make this slide deck available for the listeners. in that the exchange provider route is kind of more of that point-to-point connection that the customer establishes to that ExpressRoute exchange provider location into Azure, and the network service provider option is where the customer is actually leveraging some managed WAN provider like AT&T NetBond or one of those types of services. That they have multiple sites connected into that service, and then that carrier has a connection directly back to us. So there's we have partners, carrier partners that actually have this level of connectivity that customers can leverage, and that list of carriers is growing all the time. AT&T, I think, was one of the first ones. I know Verizon's on the list, and we have more that are coming in the pipe to allow customers to have more options to connect back to us.
Yeah, that's awesome.
All right, so talking about some differences between these paths. One is when a customer is using an exchange provider, so like the Equinix, they have much higher bandwidth options available, so up to 10 gigabit circuits the customers can actually provision and have an on-ramp directly to us. The network service provider goes up to 1 gigabit, which is still a pretty, certainly a fast connection, but then the limit here, I think, is I don't know the technical reason why we actually have 1/10 the speed, but I'm guessing that it has something to do with just kind of how routing and options that the network service providers have back to our network and how they backhaul that traffic. But there are definitely some bandwidth differences between those two options. And there's also some pricing differences that the network service provider, the customer is actually going to be selecting a ExpressRoute connection based on some established level of tier or established tier that we already have available for customers to pick from. And they're going to incur some data charges for traffic that rides through that particular tier of service. And with the network service provider, the customer is already going to you're already going to have a relationship or established connection to the network service provider's cloud or wide area network service that the customer is providing, or that the carrier is providing to the customer, and the customer is going to essentially not be metered, if you will, when it comes to some of the data going from their network into Azure. So there's some pros and cons to each. And one final thing I'm going to highlight is the bottom bullet, where the customer using an exchange provider actually has to provide two routers to us, or not to us, but to the exchange provider that gets deployed into a cage to be able to establish that connectivity from their network into Azure. Whereas if they were to leverage a network service provider, that connectivity is already established. So that the AT&Ts and Verizons of the world already has redundant connectivity back to Azure. So the customer doesn't have to provide any equipment using that particular path.
Awesome. Yeah, that makes sense.
So one thing that ExpressRoute gets a little bit more complex as well, that there's some options that customers can enable, specifically this ExpressRoute Premium. And what this actually allows customers to take advantage of is using our private backbone as a vehicle or pipe for their traffic to actually flow to deployments that they might have or networks that they might have created in Western Europe or Asia Pacific. So if they have offices here and offices over in Asia, talking with Azure networks deployed in both of those locations, they can actually have traffic going between those two locations flowing over our backbone, again, instead of using any sort of wide area network service that the customer is going to have to establish between their offices, or using the public internet. So it's a way for us to expose some of our capacity to backhaul some of their traffic between some of the regions that we have Azure services sitting within. The other thing that ExpressRoute Premium does is increases the number of IP routes that the customer can define from 4,000 to 10,000. And we also increase the number of VNets. So in Azure, a VNet is quite literally a network that the customer defines with private range of IP addresses. And with ExpressRoute, customers can actually establish connectivity to 10 virtual networks defined in Azure. And with ExpressRoute Premium, the customer, depending on the tier of service that they choose, it can get anywhere from 20 to 100 VNets that they can actually establish connectivity into.
Wow. And it looks like once you have ExpressRoute, you can just enable Premium by using a PowerShell command.
Yeah, absolutely. So once that service is set up, it quite literally is a PowerShell command. And actually, PowerShell can also be used to increase the size, your tier of service. So if a customer is using an exchange provider as an example, and they have a 50 megabit circuit and they want to increase it to 100 or 200 megabits, they can also do that with a PowerShell commandlet as well.
Wow, just another good example of why PowerShell is important.
That's right. So this is just an example of ExpressRoute Premium, showing a customer with a data center in the U.S. and one over here in Europe. But the site here in Europe has a circuit back to a ExpressRoute peering location, so like an Equinix type peering provider, and traffic that actually is the customer might have virtual networks established within Azure as well, with VMs or services deployed into it. And if they had a virtual machine sitting here in the U.S. That a server here in Europe needs to access, that would actually leverage our private backbone to actually carry that traffic back over to the U.S. So this is kind of an illustrative example of how we can. The ExpressRoute Premium allows customers to backhaul some of that traffic over our private network. All right.
Yeah, that's pretty cool. So the dotted blue line, by the way, is our private backbone, right? It says MSFT backbone, but I just want to point out that that's a private backbone. That's not.
That's correct.
Not over the internet. That's a private network that we set up with the exchange providers.
Yep, and actually even more specifically, it's the private network that we actually have, on the bottom of the Atlantic and Pacific, that we actually are rolling out our own fiber. So we own fiber. So I think some we probably are leasing, but we also own a great deal of it, and we're deploying a tremendous amount of new fiber to create more of a mesh connectivity to make a more resilient network, around the globe. So it quite literally is fiber in many cases that we might actually own and have laid on the bottom of the ocean.
That's so cool.
Yeah. Yeah. What's how awesome is it to be employed at a company that that has the wherewithal and capacity and financing to be able to do something like that. I mean, you kind of think about some of the competitors, and there's only a handful of companies in the world that can actually do something like that.
Yeah, what's funny? So this has nothing to do with ExpressRoute, but yeah. I was actually, this was 20 years ago, or 24 years ago probably. I had just gotten hired at Microsoft, and Bill Gates was talking about how we were currently baseband, but at some point the whole world will be broadband, and when that happens, we'll have media and everything else that can just travel over the internet. And it was just amazing. The number one, the prediction that he made was cool, but the speed at which we got to that point is just phenomenal.
Yeah, absolutely. I mean, look at the Olympics. I mean, that ran in Azure. A very widely publicized media experience that was actually entirely hosted in Azure, and I mean, there's millions of concurrent users that were actually watching different events over that. I mean, it's just incredible when you think about a high definition video streaming over the internet. I mean, that's a tremendous amount of bandwidth. So
yeah, that's just awesome. Also, the NFL, right? Aren't we using Azure as the backbone for the NFL project that we have going?
Yeah, I know there's a number of sporting providers. Some individual teams that are actually looking at using Azure for streaming some media, and I know that there's some different racing events that are using Azure. So yeah, that's actually, it's a really good fit when you think about it for Azure, because I mean, if you have game day or race day, you need a bunch of capacity to be able to stream out to the viewers, and then need to turn it all off when the event is over. So no need for a customer to provision huge pipes for a couple days out of the year.
Yeah, I can't wait. I'm just, the NFL doesn't offer it yet, at least not in the United States. But at some point, you're going to be able to go in and buy essentially a season pass for the team that you like. And when that happens, my cable bill is going to get much smaller.
There you go. So I thought that, now we kind of talked about the basics and ins and outs and options that exist. We'll go through some scenarios and show, how can this be layered into a typical customer environment. And one thing I want to highlight first is that some customers might have a desire to well, let me back up a little bit. So let's say that a customer has a virtual machine sitting in a network in Azure. That virtual machine could actually access the internet directly. So as an example, we could actually have an admin logging into the server I'm pointing to and open up a browser, and it would actually completely bypass ExpressRoute circuit, the customer's on-premises network, and go directly to the internet. So let me go ahead and advance this a little bit. So customers can actually set up something or enable something called forced tunneling. And what that means is that internet-bound traffic from networks that they have defined in Azure would actually flow back over the ExpressRoute circuit, and the customer can deploy network monitoring or security appliances, or take advantage maybe existing ones they already have, to actually have that traffic flow through those devices and then back out onto the internet using whatever connectivity the customer has from their on-prem network.
Yeah, that's pretty cool. So that gives them the ability to control the data that gets published to the internet, including where the data is coming from, instead of just doing it via Azure. They can pull it back in, they can analyze it, they can make sure that it's safe and that they want to publish
Exactly.
that data, and then they can publish it.
Yep, absolutely. So maybe preventing some rogue admin from getting a server infected with malware that happens to be sitting in Azure, as an example, or highly regulated industries that have requirements for monitoring and logging of what internet activity is occurring from devices in their network.
Yeah, and I think there's some other examples of that as well, right? Like with Office 365. Let's say that customer has ExpressRoute. You had this on an earlier slide,
right?
Where even though it wasn't Azure, we were using the ExpressRoute circuit to get to Office 365. And there are some scenarios where that would be great if customers have email users, of course, that are in the office, that are on their local networks. And so you probably want to use that fast circuit to get to the Office 365 stuff. But then you also have people that may be working from home, and they may not need to VPN into the corporate network to go across the ExpressRoute circuit to get to the Office 365 components. But you could essentially, I guess, create an ADFS rule that says, hey, you have to come in through this network. But
right.
You could also create an ADFS rule that says, hey, if you're not on this network, that's okay. We'll let you directly access those services.
Right, and that was actually something we recently introduced back at, I think it was sometime in the beginning of summer, called User-Defined Routing. So customers can actually, this is a simple all or nothing rule, it would basically block all of this traffic, but customers can get into very sophisticated policies that they can establish. So within this network sitting in Azure, they can subnet it out farther and actually set up policies where one subnet actually might be able to access the internet directly, maybe as a public-facing web application or a farm of servers that are publicly accessible, but they want everything else in the other VNet to have this forced tunneling enabled. So the user-defined routing actually allows customers to set up very sophisticated rules. You can use network security groups, which is another thing within Azure VNet. They can create policies at a network interface card level. So on this server, they can have up to 16 network interfaces. And they can set up individual rules on each NIC on what sort of policies, inbound and outbound policies the customers want to define. So we have very granular levels of security and policies that can be set up. This is just a very simple flag that customers can define on their ExpressRoute circuit. It just says, I want to block everything and force it back over the ExpressRoute circuit.
Yeah, that's cool.
Yeah.
Lots of flexibility.
Yeah, absolutely. So this is a connection at its basic level, most basic level. So this is actually showing a customer might have multiple sites here on the left-hand side using some sort of network service provider MPLS circuit, and these are the private edge routers that the customer actually has deployed into a peering location, or that the network service provider has wired into Microsoft routers that are deployed in that particular peering location as well. So irrespective of the path the customer can uses, there's redundant routers at both ends. Both the either the customer provides or that the network service provider has in place, as well as equipment that we have deployed to those facilities. This is just depicting a more real picture of how that actually works. In this case, we have a VNet, much like the other slide, that we have the forced tunneling enabled that forces that traffic back through the customer's network to get back out on the internet. So this is more of a basic network topology of how customers can define or take advantage of ExpressRoute. We can look at some more more advanced scenarios where a customer might have multiple VNets, so maybe in the U.S. East and U.S. West, and the customer can actually, as I mentioned earlier, that ExpressRoute can actually allow you to connect up to 10 VNets without the premium add-on. So in this case, we actually have 2 that are connected back to a particular ExpressRoute pipe. And the interesting thing about this, you see here that we're still connecting to Washington, D.C. This is just the on-ramp into the Azure backbone. So U.S. East might actually not be in Washington, D.C., but customers' traffic that originates from that peering location in Washington, D.C. to U.S. East is going to ride on our very, very high capacity private backbone. So customer establishes a connection to one of many locations, and then any traffic that they that is destined for any location, in the U.S. if they don't have the premium option, or globally if they're using the premium option, is going to ride our private backbone. So the interesting thing to note here is that traffic for U.S. West is actually going to go flow to and from this circuit, and East is going to flow to and from the circuit. But there's no connectivity between these VNets in Azure. So the thing to note on here, that if a customer has a topology like this, if they have a server here that's replicating data to a server here, that traffic is going to flow over to the customer's network and back around into the other location. So the next picture shows a way that customers could potentially alleviate that. Let me just go ahead and build that out. So in this case, customers can actually, or this picture rather, showing in the same picture as what was on the previous slide, but there's also a site-to-site VPN connection between these two circuits, or these two VNets rather. I shouldn't say circuits. These two VNets in Azure. So the way this works is the traffic. And I was talking in the earlier example, if there was a server here that needs to connect to a server in maybe a different Azure location. These two VNets may or may not be in the same physical location. That traffic, instead of going over the customer's ExpressRoute circuit, is going to ride over this VPN tunnel that's established within Azure. And this is something we demoed on a previous talk, when I kind of set up all that plumbing and showed how that traffic was flowing over a VPN. Site-to-site VPN is what we call it in Azure. There is some throughput limits on this. The VPNs or VPN gateways, the largest gateway we have is limited, I think, to 200 megabits. So the traffic that rides over this red line, might be bottlenecked depending on the nature and degree and how much volume of traffic is actually being sent over that. But in this scenario, we're not congesting the customer's ExpressRoute circuit. And in this example also, this is illustrating something I talked about earlier, where you might have some sort of web-facing or public-facing web presence that needs to connect to the internet. And then in this case, maybe those web servers are connecting to, back-end database services or, web services that the customer wants to have protected and firewalled, that the customer can have more control over the services running down in here. And these servers would just connect directly, to those back-end services using that red connection point. And if you look at this, one would think that a customer, or I'm sorry, that a nefarious user could, from the internet, be able to hit the VNet that's public and ride over this VPN circuit back into, or VPN tunnel, back into this network. This is not something that is allowed, so that particular scenario is blocked, because what actually happens is, customer or external user would be establishing a connection to the server. This server would actually be establishing a connection directly to this machine. So there's rules and policies in place here. This is not just going to get an external user or nefarious user carte blanche access down here to private infrastructure, or worse off, private infrastructure over here over the ExpressRoute circuit.
Yeah. So hey, let me ask you a question. That VPN
Sure.
link. That's also going over, just so that everybody understands, I think that's also going over our infrastructure, right? Not out to the public internet. We're not creating a VPN across the public internet.
That is absolutely correct. This is actually, that's a really good point. So in the example, the very first slide I depicted where I said that the site-to-site VPN is a connection option customers have, that would actually be an example of that would be this data center the customer has connecting to this Azure VNet using a VPN circuit, and that would be going over public internet infrastructure.
Right.
Yeah,
right.
But
connecting the two sites
private.
with VPN.
Yep, you got it. That's private. Yep, I was just comparing contrast because the technology is the same. The product the customers use is called Azure Site-to-Site VPN, but the way it's done internal to Azure is different than external. Yep, that's a really good point.
I just want to make sure that we make the point that nobody is exposed to the internet unless they absolutely want to be exposed to the internet. Even if you set up the VPN between the two Azure sites like we have here between the two VNets, that's still not a public internet connection.
That's correct. Yep. You got it. So this is actually, I forgot there was a final build on here. That's without that forced tunneling that we talked about. So this actually, let me go ahead and let this build out here. So this actually is with forced tunneling enabled, and the interesting thing about this is that public traffic for that this server might be going out to Windows Update services, for example, is going to flow back over the customer's ExpressRoute circuit and actually hits if it's truly public. If it's hitting a public service, maybe Bing.com or NFL.com or something along those lines, then the customer can using that forced tunneling we talked about, it'll actually go back to the customer's network and use the customer's network to actually go back out to the internet. What this is depicting is one of these servers hitting a Azure public service, so Azure Storage or HD Insight or one of those types of services. And this traffic, when you have forced tunneling enabled, I just want to highlight that there's some interesting behaviors of this. It's actually going to go back and hit the customer's edge router, and the router is going to say, hey, I know about this public service you're trying to hit, and it's going to route it back over to the Microsoft router. So the traffic makes a little bit different trip than actually going directly from here to public service if forced tunneling was disabled. So this is just kind of showing that some of those public services are treated a little bit differently and take a different path if the customer has that enabled. So it's kind of showing what customers would expect and kind of physically how that traffic bounces around.
Yeah, it's all just routing.
Yeah, exactly. Yeah. But I mean, it's one thing to note. I mean, if this server is doing massive amounts of data transfers, it actually is going to be transiting this customer's ExpressRoute circuit. So if they have forced tunneling enabled, so some things that customers have to be aware of. It's options that exist for a reason, but when they enable them, other things alters the behavior based on those
Yeah,
routing.
yeah, absolutely.
Yeah.
It's something that they just have to calculate and prepare for.
Yeah, exactly. You got it. Um, so this is actually the more complex example I talked about with user-defined routing, and this is showing where a customer can, again, they have from their site using ExpressRoute into a VNet. It's in the East US, and they have this VNet. You have different subnets defined within this VNet. And the cool thing is that we have in the Azure Marketplace a variety of network security appliances that customers can deploy virtually into Azure. So in the earlier example, we showed backhauling traffic, internet destined traffic from Azure back to over ExpressRoute to the customer's network and back out. In this case, the customer can actually deploy security appliances right in Azure, such as Barracuda networks and F5, Cisco. There's a number of different vendors that you can quite literally go in the Azure portal and say, I want to create a Barracuda network security appliance, deploy it into Azure, all of the define some parameters of what network you want to actually attach it to, and then you can actually define rules using this user-defined routing to say the traffic destined for the internet from this web tier is going to flow through the security appliance, and then you get some other inherent benefits. Now you have inbound traffic being monitored and some additional protections put into place. Azure has distributed denial of service protection. These network security appliances are a little bit more sophisticated, and you can actually, and customer knowing his or her traffic patterns that are coming into their application, they can actually set up rules to be able to look for cross-site scripting attacks or those types of abnormal connections that might be coming from the internet, or connection attempts that might be coming from the internet into their web tier. This security appliance can also be set up to block and remediate some of those situations as well. So user-defined routing is a fairly new in ExpressRoute, but it really opens the door for a lot of very sophisticated and complex scenarios. This is just kind of showing a simpler approach. But one thing I do think is cool is the number of partners that we have, with options and services that can be deployed right from the Azure Marketplace into Azure with a couple of clicks. You have a Barracuda device sitting up in Azure.
Yeah, the really cool thing about that is exactly what its name says, right? User-defined routing, which means that you actually have control over what happens with your data, even in the Azure environment.
You got it. Yep. So those were just some of the basic scenarios. Obviously there's much more you can do, but I just wanted to show some problems or challenges or business scenarios that a customer might be challenged with, and how ExpressRoute comes into the fold to try to bridge that customer's situation, or more specifically their network, back into Azure. And as you mentioned, as we talked about a number of times, it's a private connection, not making use of the internet. So this is especially appealing to government institutions or highly regulated environments, financial institutions, where they don't want to have any other traffic flowing over the public internet. ExpressRoute is a really good solution for being able to put into play and address some of those requirements that customers have.
Yeah, absolutely. I'm really excited about the technology. I know a lot of customers have, asked about the technology recently just because kind of word of mouth, and I think, they've read it in some white paper or something like that. So it looks to be a fairly promising and popular option for customers.
Yep, absolutely. Yep. For customers just doing some experimentation, the easiest and path to do some network connectivity between their network and Azure is by far and away VPN. There's no circuit provisioning, no third parties involved, and certainly it's a lot less costly. So just from a prototyping experimentation standpoint, VPN I think still has a really good fit. And then also ExpressRoute is sort of the big hammer solution. If a customer is not in one of those highly regulated industries, doesn't have a need for huge pipes back into Azure, VPN still certainly has a play, and is a much less costly option that customers can look at too. So bottom line is we make all of these Lego blocks available for customers. They pick what they want, they configure it how they want, And I think that's really the cool flexibility that Azure brings to the table for customers to take advantage of.
So is there a good place customers could go to get just an overview of what ExpressRoute is and how it can help them?
Yeah, absolutely. We'll leave it in the show notes that there's this site that I have open right now is actually showing all of the connectivity locations that we have today. And this, like I said, this list is always growing, as well as details on the carriers and partners that we have that customers can actually establish connectivity through. So this is certainly the most up-to-date list and location that customers can use to get information on pricing, as well as locations. Another thing that we'll leave in the show notes is this is actually a really good blog that somebody on the networking team put together that compares and contrasts all of the differences between site-to-site, point-to-site VPN, as well as ExpressRoute via the exchange provider, so like the Equinix type providers, or a network service provider, and has details of some of the bandwidth limitations, details on encryption protocols and so forth.
Well, as always, that was awesome. I really appreciate you doing this for us, Ryan.
Yeah, no problem. I think the goal here, and to your point earlier, hopefully we simplified what ExpressRoute is, how it plays into different scenarios customers have. As you mentioned, a lot of customers are talking about it and asking questions about it, and it can be a little overwhelming just because network connectivity by nature has so many options available. Sometimes it's difficult to understand. So hopefully we achieved our goal today.
Yeah, so the other thing, and this is just an aside, right, has nothing to do with Azure or ExpressRoute, but just wanted to mention that depending on when this airs, you'll either be episode 72, 73, or 74, which is pretty cool. Yeah.
Yeah.
We've got something special cooking for episode 75.
Okay, well, that's a really
Yeah.
good milestone.
Yeah, but you're almost there. You're almost there. But I'm mentioning that because, as everybody that's watching the show knows, you've been kind of a standard guest. We've had you on multiple times, and it's certainly been awesome. And I can't wait to see what you can bring us between episodes 75 and 100.
Awesome. Yep. No problem. With the rate that we're releasing capabilities and features and enhancements in Azure. I think last year there was over 100 new products that were actually launched in Azure, so it's a challenge. I know even for us internally to keep on top of, and I imagine even equally as daunting for customers to keep on top of. So hopefully we'll as some of those new things roll out, I think it'd be some good topics for future shows.
Yeah, absolutely. All right, guys. Well, that's it for this episode. So without further ado, that's your taste of Premiere.
All right. See you later.